Welcome back. In today's lesson, we're going to use our knowledge of Pythagoras' theorem to solve various problems. But before we dive into these word problems, let's review some geometrical concepts that we've studied in the past. Okay. The first geometric concept we're going to look at is the rectangle. Now, in a rectangle, right angles exist between adjacent sides. And a right triangle consists of opposite sides that are parallel and congruent to each other. And then we take a line and we connect opposite angles. We form what's called a diagonal. Now notice the diagonal divides this right triangle, this rectangle, into two equal triangles, and they're both right triangles. So right triangles, we can use Pythagorean's theorem to solve for a missing side of the rectangle or for the missing diagonal of the rectangle. Next, let's review our knowledge of squares and rhombuses. In a square and a rhombus, the diagonals bisect each other at right angles. So recall, squares and rhombuses have all sides that are congruent. So that means on this square, all four sides have equal length. The two diagonals are perpendicular bisectors of each other. So that means that inside a square, we have four right triangles that are formed. A rhombus also has all four sides that are congruent or equal length, and the diagonals also bisect each other and are perpendicular, but the difference is here that the two diagonals are of different lengths. In addition to a right triangle, you need to know some information about isosceles triangles, which means two equal sides, and equilateral triangles, which mean three equal sides. Now, here this line that bisects the isosceles triangle that starts at the angle that's formed by the two congruent sides and is perpendicular to the bottom, the other side, which is called the base. That line segment, that perpendicular bisector, is called an altitude, or the height of the triangle. Now notice the altitude divides an isosceles triangle into two congruent triangles, and the altitude on the equilateral triangle does the same. And now a few formulas that we need to review about these important geometric figures. On the perimeter of a rectangle, you take the 2 times the length plus 2 times the width. You're adding up all four sides of the rectangle. To find the area of a rectangle, you just take length times width. The perimeter of a square is 4 times side length. The perimeter of a rhombus is also 4 times side length. But the area of a square is length times width, or side squared. But for a rhombus, it's a little bit different. So area is equal to 1/2 diagonal 1 times diagonal 2. The perimeter of a triangle is you add up all the sides. For an isosceles, two sides are the same length. So I have 2x plus y. The area of any triangle is 1/2 base times height. In this case, y is my base, and I'll call A my height for altitude. Likewise, to find the perimeter of an equilateral triangle, we add up all three sides. And so in this case, perimeter would be equal to 3 times x. And area is equal to 1/2 base. In this case, x is the base, times height, which is altitude. So 1/2 xa. The application problems in this chapter, there are 7 steps that you need to follow. For the first one, draw a neat, clear diagram of the situation. So draw a picture so that you know exactly which kind of shape you're dealing with and which kind of figure you are. Then on the picture, label your known lengths and make sure you draw in the right triangle so we know which angle has the right angle. Step 3, place a variable to identify the length of the unknown. You can use x or any letter that you want. Since we're dealing with right triangles in this section, write down the Pythagorean theorem for the given information. So use Pythagorean theorem to solve for one of your missing unknowns. Then solve the equation, and finally write your answer in sentence form. If your problem has units of measurement, make sure you include units of measurements in your answer. First example, we're asked to find the length of the diagonal of a rectangle. And so we're going to start by drawing a diagram of the rectangle. Identify the sides that we know. So we know that the length is 8 centimeters. The width is 5 centimeters. And we do not know the diagonal, which they tell us to identify as x. Now we're going to set our Pythagorean theorem to solve for the unknown side. And we get x is equal to the square root of 89. In this problem, we asked to find the nearest tenth. So we need to actually plug this into our calculator and round to the tenths place. So notice that when I estimate and round here, I switch from equal sign to approximate symbol. And then I need to write my answer in sentence form. After reading example 2, we're going to start by drawing our diagram. So I need to have a 30-foot pole, and then attach to the top of the pole down to a point 20 feet from the base of the pole is my guy wire, which I'll label as W for wire. So I've labeled my known and unknown, and since I have a right triangle here, we're going to set this up with Pythagorean theorem. And y is equal to the square root of 1,300, which that means W is equal to about 36.1 feet. Final step, write my answer in sentence form. So the guy wire must be about 31.6 feet long. In this third example, the sketch is already drawn for us, so we don't have to redraw it. But we're asked to find how high is the washing line above the ground. So we do need to draw that line, that altitude, into our diagram and label it with a variable. I'm going to choose h for height. And we're going to give our answer to 1 decimal place. So I know by drawing that altitude down, I formed a right triangle. When I form this right triangle, I bisect this third side, because this is an isosceles triangle, so that third side is 1.5 meters long, and I can use our Pythagorean theorem to solve for h. So h is equal to the square root of 175. Using our calculator, that is approximately 1.3 meters high. So in sentence form, I could write that the washing line is approximately 1.3 meters above the ground. Now for part B. Now we're given the same sheet, so I need my two sides are going to be the same length. They're going to be 2 meters each, but this time my height of the washing line is 1.25 meters above the ground, not that 1.3. And I'm asked to figure out the width of the base of the tent, which will be this 2x, this full width here. So I'm going to start by using Pythagorean theorem with our x squared and our plus 1.25 squared equals to 2 squared. Solve for that x to get half our length of the base. I have x is equal to the square root of 2.4375. Now notice that I am using more than 1 decimal place until this last step after I take the square root. Do not approximate earlier than this. So I know that x is equal to 1.56124595 times that by 2. Now here, this is the final step. This is where I round to 1 decimal place. Please do not round before your final answer. You'll get called what, a rounding error, and you might miss the answer. So write my answer in sentence form. I would say that the width of the base of the tent is approximately 3.1 meters. Our last problem today, we're going to look at a rhombus who has diagonals of 6 centimeters and 8 centimeters. Now recall, a rhombus has all 4 sides that are congruent and the diagonals bisect each other. So if I have a diagonal that's 8 centimeters long, then each side here is 4 centimeters, and respectively on the other diagonal, they're 3 centimeters each. Now notice a rhombus's diagonals bisect each other, so we form 4 right triangles. And let's look at this first right triangle, and we can use Pythagorean's theorem to solve for the hypotenuse of x. And we find that each side of the rhombus is 5 centimeters long. So writing my answer in sentence form, the length of the sides of the rhombus is 5 centimeters.